Welcome to Numbers and Beyond. Um, Today's topic is hypothesis testing, and we are discussing the types of the error. There are two types of the errors in hypothesis testing: type 1 error and type 2 error. We're gonna see, what's the meaning of these two errors definition, and how we can apply them into the conceptual problem solving, right? So let's first simply discuss the definition of the type 1 and the type 2 error. So if you look at the type 1 error definition, type 1 error definition is saying T1 error, it says it's a probability. It's a probability of, under a condition that if the null hypothesis is true, then what's the condition that your alternative hypothesis will be accepted. Now if you see, it's clearly saying us it's a conditional probability and the condition is null hypothesis. Now where is this condition applied? So this condition is applied on the distribution. That means if I'm looking at the distribution of normal distribution, which is defined as, if my random variable is following normal distribution defined as mu and sigma square, right? Mu is the population mean and sigma is the population standard deviation. Then under the hypothesis, what's the value of the mu? So if you are claiming that the population mean is 2, for instance, right, then we will find this probability using this value of population mean. But now, so this is the meaning of this condition, H0 is true for the normal distribution. But the same thing if I say for the binomial distribution, we don't have the curve, we have the, let's say this as the histogram of the binomial distribution, right? We know binomial distribution is defined as B and P, and the claim is that the probability for one success is, let's say, 0.5. This is a claim. So while finding the probability, now here in type 1 error, while we will find the probability of the type 1 error, we will use, the meaning of H0 is that you're going to use this value of mu probability and this value of mu. And similarly for Poisson, the value of the average, which is lambda, defined under null hypothesis, is used to calculate the probability. That's the meaning of the condition. However, then what's the meaning of this H1 is accepted? H1 is accepted means now when you say that the condition is on H0, the H0 is true, that means it is for sure your data is following this graph. So if your data is following this graph, the alternative hypothesis, let's say, is mu greater than 2. Then which part of the graph shows, because the graph is basis the null hypothesis, so there are very less chances that that the alternative statement will be true. So that means critical region, which refers to the acceptance of, in which we accept your null hypothesis, alternative hypothesis, right? That is whose probability I'm looking for in type 1 error. So if my alternative hypothesis is mu greater than 2, then definitely it will fall on the right side, right? If it is H1 mu is not equal to 2, then it will fall on the both side, right? So if I try to annotate it now, this is where H0 is true and this is where H1, and I am trying to find the probability of the red region here, which is called the critical region, right? So Type 1 error is nothing but the probability of the critical region in graph of H0, which is same as that of your significance level. So let's try to apply the same understanding to this problem, right? So every problem we are given certain condition. When you say H0 is true, H1 is true, right? So there is some condition when H0 will be true, and there is some condition for the data when H1 will be true. So let's try to look for that. So first we have to look for the distribution. So the number of the fish, which is X, let's say, it is following the Poisson distribution. So X is following Poisson. 1 hour can be modeled. The owner of the lakes claims that, because it's a statement given in advertising, so that means it's a claim. So the claim that the average fish caught is 3. So the average fish caught in 1 hour is 3. So that means under null hypothesis, when you're gonna sketch the curve, the average is going to be at 3 in the graph of H0, what I was explaining over here, right? So what value is this mu? This value is what defined in null hypothesis, and same time you can define your null hypothesis that lambda is equals to 3, right? So, but if we go further, Tom, a keen fisherman, is not convinced and thinks that it is less than 3. So when it says it's less than 3, so this is the alternative claim, right? So this statement says that it is the alternative claim. So my H1 is lambda is less than 3, right? Now he decides to set up the following test. The Tom, now this is really important. Everywhere in the question of the Poisson and the binomial, you will be given a condition when your null or alternative is going to be true, right? So the Tom is saying if he fish for 1 hour and if he catches fewer than 2 fish, he will reject Emily's claim. Now this line is very important. If he catches fewer than 2 fish, that means if X is less than 2. So if I just annotate it over here, if he catches fewer than 2 fish, that means if X is strictly less than 2, he will reject Emily's claim. So what is her claim? Her claim was that the average is 3. So rejecting Emily's claim, rejecting her claim, that means rejecting H0. Rejecting H0 means accepting H1. I always suggest that whatever is the condition, first you just copy paste that. So the condition is if X is less than 2, then claim is rejected. I always say try to rewrite this claim in terms of the symbols. The claim is rejected means that H0 is false, and always create the supplementary negative statement of it. So X less than 2 means that X opposite will be X greater than equal to 2, and if H0 is false, right, over here it will become H1 is true. H1 is false, sorry. And this means H0 is false means H1 is true. And H1 is false here means H0 is true. So writing in terms of true is really important, because your type 1, type 2 error definition is in terms of H1 is accepted or H0 is accepted, right? This is really important. If you crack this one, then the definition is easy to, because from here only you can recreate the definition of type 1 error. So let's rewrite the definition of type 1 error. So the type 1 error definition is that we accept null hypothesis, alternative hypothesis, however the H0 is true. So the simple meaning of the H naught is true is to give you, okay, this question is of Poisson, what's the value of the lambda? So we want to take this value of the lambda because this H naught true means hypothesis that lambda is equal to 3. So given that lambda is equal to 3. However, the first except H1, that means look in the condition. So this is the condition. Now where is except H1? Over here. So what's the value of the X? So the except H1 is always going to be the claim on the random variable value, either less than or greater than depending upon the question. So here it will means X less than 2, and I can say that probability X strictly less than 2 means less than equal to 1. And now you know how to do it with the JDC. You simply go to Poisson distribution and enter your enter your lower bound, because less than 1 means lower bound is 0, upper bound is 1, and your lambda is 3. With this you will get the type 1 error probability. So this is what type 1 error is, right? You have to look for two things. One, the hypothesis is going to give you the condition, the value of the parameter of the distribution, and the condition given in the question is going to give you the range of the X, right? So let's try to apply it on the type 2 error also. So if we now look at the type 2 error, go back to the type 2 error definition, and we will come back to that question to do the type 2 error. It's the probability of, now this is the reverse. Type 1 says that the distribution, look at the distribution of H naught, but the type 2 says that look at the distribution of H1, right? Given that H1 is, now H1 is true, what's the probability that H naught is true? Now this seems really confusing. What does this mean? Now let's go back to this question. Emily was claiming that the average is 3. What if Emily is wrong, right? Actual average is not 3, right? So if you see, the alternative claim for the Tom was that the actual average is less than 3. We said that the Emily is saying the average is 3, but the Tom says that average is less than 3. But how much less than 3, right? Are we given that? So to find the type 2 error probability, we should have this less than 3 value, right? That how much less than 3. So are we given that? Now we will look at with respect to H1 average defined in H1, what's the probability for H naught to be true, right? So that's a definition. So that means now I'm going to look at the graph of H1. So the value at the center over here, because it's a Poisson is defined by lambda. So here I have to take lambda less than 3, which in this question means 2.5. So now you will be able to redefine your question, use this, because if you read the question to find the type 2 error probability, because if you read the question, it says the average number caught is actually 2.5, because Emily came out to be wrong. So actually it is less than 3 only what Tom